Hello, MATLAB and Python fans! Today we're going to be using MATLAB with Python on a TensorFlow example on Google Colab. Let's get started. It's going to be a wild session. So some of the steps going to be discovering the new Google Colab terminal, and there's a bit of a Linux reality to it, but don't worry, I'll get you covered. We're going to use the MATLAB package manager npm to install MATLAB. We're going to be logging into your MATLAB account, installing a bunch of dependencies like Deep Learning Toolbox and so on, discovering the available GPUs that are on Google Colab, training a network, exporting the network to TensorFlow, and connecting to the MATLAB engine from Python in order to test the TensorFlow network that we've exported in Google Colab. All of this. It's going to be about 5-10 minutes. Let's go. So first of all, let me show you here the blog post that you may have been catching 3 days ago about the new terminal that is available for everyone on Google Colab. And this is what it looks like, and I'm going to jump in it in a minute to give you a sense of how you can use it in order to run MATLAB in Google Colab. So let's go in a new notebook over here. The first thing that I'm going to make sure that I do is that I connect to a GPU instance, because that's what we'll be using in order to train our neural network in this example. Okay, and now I want to find the terminal that is over here. Perfect. We have a terminal. So it's going to be running a Linux shell, essentially, with Bash. So what I'm going to be using is a script that I'm going to simply get from my GitHub gist. Here it's like a lightweight contribution on GitHub. So you can get here this link on my GitHub profile. And what we're going to do is we're going to wget, make sure that wget, not zget. And here, pasting is going to be kind of weird. You cannot Control V, Control C, Control V, so I'm going to need to do that here. Perfect. And as you'll see, it's available here in your system file system. You can do ls to look at the fact that the file is over there. And now what we want to be doing is we want to be here executing this shell command. So still not Control V, it's gonna sometimes, and when you copy it from the shell, as you can see, it's adding those weird, so make sure that it's spelled correctly. And now you have some sort of a problem with permission, and which is kind of normal if you're not familiar with Linux. So in order to solve this, what we'll be doing here is we'll be using the chmod command with +x to change the permission. So this is like a permission setting in Linux. I don't want you to become an expert in Linux, but I'm going to be changing this to be able to execute it. So this is +x is executable. So let's try again, and here we go. We're going to be getting npm, okay, and npm installing MATLAB. So as you can see, npm and executable is over here. So 73 megabyte. Okay, so let's keep it over there for now. Perfect. And we'll wait until this is done. In the meantime, let me show you the example that we will be using over here. So we will be using MATLAB with TensorFlow. It's going to be something quite similar to this article that this blog post that we had done with Sibilla a while back. But instead of using Jupyter Notebook as a vanilla, here, local server will be using a hosted version of Jupyter, which is Google Colab. So most of it's like you don't need to be, pip installing anything. We'll be using the Google Colab platform for that. But what is interesting here is this example is essentially going to be doing the same, where we'll be developing a long short-term memory network, LSTM network in MATLAB. We'll be training it on Google Colab in MATLAB, and then we'll be exporting it into a TensorFlow network. So we'll be doing the same here, and then we'll be able to test and make sure that the neural network has been properly trained in MATLAB. So we won't be doing the training in Python. We'll be doing it in MATLAB in this case. And the example that I want to be using is one of the top examples from the documentation for our deep learning toolbox. It's doing time series forecasting, which I really like. So we'll be doing this example over here. And let me just simply we'll copy the example over here. Okay, so let's go back to Google Colab, and it seems like installation ran smoothly. So let me just go back up a little bit, just make sure that we see what are the steps that have been taken. Here, installation complete. So we've installed MATLAB. There's a set of base dependencies for the image. So it's just a bunch of, as you can see here, Linux package, Ubuntu packages that have been downloaded. I'm not going to go into detail. And then I think if we scroll further down, there is also here some Python packages, the MATLAB, the Jupyter MATLAB proxy, as well as the MATLAB engine. So those are the dependencies on Python that would be used for this example. And if we scroll down, okay, setting it up properly, some ports, some stuff, okay. So now I'm going to simply copy here the token, right click, copy, okay, and go back to my notebook. So what I need here is an extra line of code, which I'll probably also add to my GitHub repo. And here, what it does is it's going to be forwarding a port. And now I have here my token over here, okay, in order to authenticate and log in with your MATLAB account, Networks account. Okay, logging in, that's me. Next, sign on, perfect, done. You may face something else, which I will probably add somewhere as a documentation, a workflow, which enables the same with a one-time password. So maybe the first time that you do that, you may be faced with another slightly different workflow where it'll ask you for a one-time password to go get from your MathWorks account. But don't freak out, it's actually quite straightforward. And once you've done it once, it's going to be the same as what I'm doing right now. Let me pause for a minute. Okay, so here we are back, and MATLAB started in about 1-2 minutes, I would say, in the same space, as you can see from your Google Colab. And you can also see it from here, the URL, colab.dev. So this is 25A, as you can recognize your Copilot chat. I'm going to close this. I'm going to remove those not new to MATLAB, so no, thank you. And here, something that says that I'm running as root, which is fine. Probably don't need to do anything about it. I'm at the root. So now let me go get my example, my time series forecasting example. I'm going to copy the command over here for the example, and I'm going to retrieve it in MATLAB. Here we are. We're going to be using here a live script, so no need to pay attention to this message. I'm just going to close this for a moment. I'm going to be not spoiling you all the fun, so I'll be clearing all of the outputs, and we can discover this together. The first step would be to load the data. So here we have a waveform. It's a bunch of cell arrays. We're going to be manipulating the data, preparing the data set. Okay. So perfect. This is all prepared. Now let's define the neural network, and something's going to go wrong. Yep, we don't have the deep learning toolbox. So here, if you click on it, and that's one of the caveats in this workflow, is that you cannot install add-ons with the add-on explorer, which is fine. I'm going to show you another mechanism for you to do that. So let's go back here to the root of my content. And I'm going to be using one of the line of code that is inside of this script, which is npm install. So let me just show you quickly. This is a page for npm install. You can find it on our documentation. It's going to tell you how this is working. And here, as you can see, you can give a bunch of products, but also support packages inside of the argument products. And that's what we'll be doing here, adding additional products to the image. So let me do that here with Deep Learning Toolbox. I'm going to be using here the terminal. You could also do that from the terminal in Google Colab, but that's actually essentially the same terminal here. And now you might be asking yourself, how do I get the exact name for the product? So if you go to one of the product page, and so parallel computing is one of the dependencies we'll be needing. If you go back to this here product page, this is essentially here all of the names of products that we need. So let me do that here. Deep Learning Toolbox, then statistics and machine learning is also going to be a required dependency, and then parallel computing in order to leverage the underlying GPU. Okay, so now just make sure that you replace all of the spaces with underscore. There we go. C'est parti. Let me wait for a minute. I'm going to pause. Okay, we are back after over 5 minutes. The installation is complete. Now the thing is, we still do not have, if we look at the add-ons, we still do not have over here the Deep Learning Toolbox installed in this session, so we need to restart MATLAB. Let me do that over here. Restart MATLAB. I want to restart it. And unfortunately, that's what you'll need to do. Anytime that you add a dependency, you'll need to restart your session. In the meantime, let me show you the nice GPU that we have available. There's a command called NVIDIA SMI here. It shows you here that you have a Tesla T4. That's the memory, 15 gig of RAM. And yep, that's what we'll be using, for example, to train a neural network. Okay, so in the meantime, MATLAB restarted. And now we should be able to resume from where we left it with this example. Control Enter, and now Control Enter, number of channel. Come on. Okay, now I need to go back to the appropriate folder, which of course I wasn't in the right folder. Let me load all of those data in memory. Perfect. Those are my data, and now I'm gonna be able to finally define my neural network, specify the training option with the optimizer Adam, the number of epoch 200, and finally train net. let me make this bigger. We actually have a nice option now where we can make it in this focused view where you can see the app. And as you can see, it's automatically using the GPU that we have underlying, which is much faster than I would have done on a CPU. So really great. Let me come back to you in a couple minutes once this is done. So probably, yeah, less than 2 minutes, about a minute and something. We've trained our neural network. The training loss is converging. It's fairly low, so we can go back to our desktop. I'm gonna minimize this window over here, and here we can test the recurrent neural network that we've just trained. So let's see. Okay, we can calculate the root mean square error, and we can also evaluate it on future time steps. So first on an open loop, so you'll see the image will just be comparing it with the forecast with the input. We just take here an offset, and we just display the state, and we predict the future, and we just compare it with the actual. This gives you a sense as to how how performant that is, which is like honestly pretty good. And here you can also use a closed loop forecast. So here you completely displace the offset, and you really look at beyond 190 something time steps. So now it's all fine and good. I want to export my network to not to Simulink, to TensorFlow. Jeez. And as you'll see, it's another support package. So net, and I'm going to call it forecast model. And as you can see, unfortunately, you need this support package. So I'm going to click on it. But here, actually, let me go back and select the name of this package. Search file exchange. And what we can simply do is here, that's the one, download it. Okay, and let me simply do that. And this will actually work. You won't need to restart your session, unlike for MathWorks toolboxes, which is kind of nice. So we're gonna install. Okay, accept. Here we go. I can open example, why not? Okay, that's an example on how to use it. Let me go back over here. And now let me try that again. Perfect, we have this model that has been generated, the TensorFlow model. Now let me go back for the final stage inside of Google Colab in order to test this model. So first thing we need to do is import this. Oh, wait, are we in this? Oh, damn it. Let me actually do that over here, and let me export it over here. Okay, perfect. So here this should appear in this file structure, forecast model. Okay. If you take a look at it like this, you can see that it's a TensorFlow model, and there's a bunch of details on it. We'll simply import it. Import, then, no, not TensorFlow, just the name of the model, forecast model, and model equal, no, forecast model dot load model. That's the method that we need to be using. And then you can do model dot summary to look at actually what the model looks like. the weight are saved as an HD5. And this is the architecture of the model. As you can see, the input shape, it's three-dimensional, so you want to make sure that you pass the data appropriately. So now what we'll do is we'll replicate the same testing as we've done with MATLAB, but inside of Python. So for that, I'm going to be importing the MATLAB engine, MATLAB.engine, which has been installed. If you recall correctly, I'm going to essentially not start it, but connect to an existing one. So in order to do that, let me switch back to MATLAB over here, matlab.engine.share engine, yes, and engine name. So that's the name of the engine. And this way, if I copy that, I can connect to this already running MATLAB, which is perfect. You can check that this is indeed the those are all of the variables that are defined on the MATLAB side. And if you want something like X, for instance, you would do something like workspace of X. And yeah, this is a MATLAB double, so you can cast it into a NumPy array. So that's what we'll be doing over here. We'll be using NumPy as NP and defining X as np.array of this. Okay, perfect. Now let me make sure that the shape is correct. X.shape. Yeah, so it's going to be an issue here, and you'll see in a minute if I try to pass this to my model dot predict X. You'll see that it's complaining because the input shape isn't correct. It's expecting a three-dimensional, but it has a two-dimensional array. So what we do in this case is we're going to be expanding the dimensions X of. Well, actually, you know what? You can do that like this. Yeah. Now let's see if X is indeed of the right shape. So that is incorrect, sorry. So let me just do np.expand dim of X around the axis equal first axis. Okay, so yeah, now we've added a dimension, perfect. So this should be working better over here. Let me assign it to Y. Okay, perfect. We've made a prediction. Now let's simply plot it. I'm going to be using matplotlib. And yes, I could do that. I'll do that plus also X. Perfect. Here we are. We've gone full circle. We've developed an algorithm, a neural network in MATLAB. We've trained it and we've exported it as a TensorFlow. We've tested it on the Python side, and now you can share it with your colleagues. Have fun.